All right, and then the one that I could actually graph, I'm going to count on this one to be my saving grace for this lesson, to show you the way that you should be graphing these parabolas to get good, like actual good results. Let's first of all figure out what the axis of symmetry is. So the axis of symmetry is going to be negative b, which is negative 10. So positive 10 over 2 times a. Well, a is 1, so it's just 10 over 2, which is 5. So my axis of symmetry is going to be at 5. X equals 5. I'm just going to put on a line to represent my axis of symmetry for now. Okay? And let's just change the color of that to red, just so it stands out. There we go. Okay, now, if I plug 5 into my equation, what do I get? 5 squared is 25 minus 50, because so 25 minus 10 times 5 is 50. So that's negative 25 plus 25. That's going to be, wait a second, is that going to be 0? If I plug in 5, I get 0? Wait a second, what does it mean if my maximum or minimum is on the x-axis? Let's try plugging in 1 and see what happens. If I plug in 1, I get 1 squared minus 10. So 1 minus 10 is negative 9 plus 25. Negative 9 plus 25 is 16. That's going to be off my graph, but at least it's not so far off my graph that I can't put it. So I'm going to... Oh, wait, hold on. I plugged in 1, didn't I? Well, 1 would be at 16. So we're way up here for 1. Okay? I meant to plug in 4 or 6. Right on either side of my point, but that's okay. So we have a point like way up there somewhere. Okay, now let's do the one I actually meant to do, 4. 4 squared is 16 minus 10 times 4. So 16 minus 40 is going to be negative 24 plus 25. That's 1. So if I put a point here at 4, I get 4, 1. If I do that for 6, I should also get 1 if this is truly the axis of symmetry. Let's see if that works. 6 times 6 is 36, so that's 6 squared, minus 60. 66 minus 60 is, 36 minus 60 is negative 24, plus 25 is 1. So that worked out too. Okay. Let's get 2 more points on here. Let's try 3. So if I plug in 3, I get 3 squared is 9 minus 30. 9 minus 30 is negative 21 plus 25 is 4. Okay? So I should have a point at 3, 4 right here. Now that means, according to the axis of symmetry, I should also have a point at 7, 4, but let's make sure. So if I plug in 7, 7 times 7 is 49. 49 minus 70 is negative 21. Negative 21 plus 25 is 4. So that works out too. I'm going to put a point there. And that's it. All right, let's go ahead and draw our graph. When I draw our graph, I'm going to keep in mind that that point that I put at 1 is probably too far off the line to actually be meaningful. I don't know. Let's include it and see what happens. So I'm just going to kind of connect all these points here with a curve. And our graph looks something like this. Okay? There it is. Notice that this one just barely kisses the x-axis at 5. So that means that it only has one solution because it just barely touches the x-axis, and that solution should be 5. Let's take a look. There it is. All right, that took us a lot of time to get through those 3 problems. Things are about to speed up now, though, as we use a graphing calculator or graphing program to solve the next several of these. So here's the thing. In order to get these into a form that we can graph them, we have to find a related function. And what we need to do is get 0 on one side. Okay, so that's the tricky thing about these graphing calculator ones, is we at least need to get 0 on a side by itself. To do that in this first one, I'm going to subtract 16x from both sides. So for letter D, I get x squared minus 16x plus 64 equals 0. And when I actually put this into the graphing calculator, I'm going to say that this equals y. So x squared minus 16x plus 64. Let's see what that gives me. X squared minus 16x plus, and let me see what it was, 64? 64. So we're going to do plus 64. And it already says that that equals f of x, so that's perfect. All right, what are my zeros for this one? Well, I see I have a, actually, hold on. I needed to shift. There we go. I only have 1 0. Looks like it's at the point 8 0. So let's see if 8 is a solution, is the only solution for this first one. And the answer is x equals 8. Okay? All I did was I graphed it, and then I looked for where it crossed the x-axis. Let's do that for the next one. But again, we're going to have to rewrite this one. So this one, again, same exact thing. X squared minus 2x plus, in this case, it's plus 4. X squared minus 2x plus 4. In fact, I could probably just change this to minus 2x plus, no. All right, let's enter it from scratch. X squared minus 2x plus 4. Okay, so there's my new graph. Uh-oh. This one doesn't actually cross the x-axis. So this one is going to have no solution. There we go. And then my last one is going to be 7x, negative 7x squared plus 3x plus 7 equals 0. So negative 7x squared. Let's get rid of this one and we'll just enter a new one. Negative 7x squared. Okay. Plus 3x. Let me just double check. Plus 3x plus 7. Okay, so let me add that to the end. Plus 7. This one crosses the x-axis in 2 places. Now notice it doesn't cross in very nice places. So if I click here, I find that it's negative 0.808. I think it's going to say to round it to the 100th. So round to the nearest 100th. So we'd say negative 0.81. I have to round up. And then on this side, it's 1.24. Negative 0.81 and 1.24. This is where, hey, 10th. It said 10th. It said 10th the whole time, and I thought it said 100th. All right, so the point on this one is that sometimes even if you tried to graph like this, how would I guess that it's negative 0.8, right? So sometimes your best bet is to use a calculator because it doesn't cross the x-axis in nice whole number or integer places. And lastly, Marcus shot an arrow while standing on a platform. The path of movement forms a parabola given by the quadratic equation negative 16t squared plus 2t plus 17, where h is the height in feet, t is the time in seconds. Find the time when the arrow hits the ground. So we're going to graph the path of the arrow. It's negative 16t squared. So negative 16t squared. Doesn't matter if I use t instead of x. It likes that one too. Plus 2t. And then let's see. That was plus 17. Plus 17. Okay. And then the question is, where does it hit the ground? Well, notice it hits the ground apparently at -1, almost -1 seconds, but that doesn't make any sense because it can't hit the ground at a negative amount of time. So instead, we're going to look at the positive value. It hits the ground at about 1.1 seconds or 1.09. Let's see, what does it tell me to round to? The problem tells me to round to the nearest 100th, which is going to be 1.10 seconds. Let's see if that's right. T equals 1.10 seconds. And all I did was I found the 0 for that function. All right, now you know how to work these problems. You're ready to do the problem set for next time.